everyone. So this week we've been working on rearranging equations. So mostly we've been multiplying equations or dividing them. We've been distributing brackets, so multiplying out those numbers in front into the whole bracket. And then we've been solving for a letter, and usually it's X, but it could be any letter, like K or M or T. And we do that by doing the opposite operation. So we make sure that we collect all of our like terms on one side of the equation, so all of our letters on one side, all of the numbers on the opposite side of that equal sign, and then we try to solve for that letter. Today, we're going to talk about two main ways that we can see linear equations. And this is going to be super important because where we're going with this is last year we did a lot of single equations with lines. This year we're going to actually solve systems of equations. And that's where this is going. So in order to do this, we need to understand that there's two ways that we normally see an equation. And the way that we don't see it very often, but we will now, is called the standard form. And in standard form, you usually see both variables, so x and y, are on one side of the equation. So if you just look down to example 1, standard form is what this is. Okay, so I have 3x plus y minus 5 equals 0. This is standard form. So usually, example, you're going to have x plus y plus some number, which we call c, is going to equal 0. Okay? So any number which is a constant, that's going to equal 0. The second way that we can see linear equations is the way that we are used to seeing it, and that's called y-intercept form. Y-intercept slope form. And the reason why it's called this is because you can see the slope and the y-intercept immediately, and that's the way that we normally see it. So that's this y equals mx plus b form. Okay? It doesn't matter which way we see our equation, we can actually rearrange them so that we can have them any way that we want. And that's what we're going to talk about today. So instead of getting a number at the end of these equations, we just want to isolate. And isolate means that we want to find our equation so that we're rewriting it either in slope-intercept form or in standard form. Okay? So for the first equation, I have 3x plus y minus 5 equals 0. And I'm asking you, or us, to rearrange this so that it's in slope-intercept form. And this means I want a y equals equation. Okay? So I start with my 3x plus y minus 5 equals 0. And I know that I want y equals, so I want my y to stay on my left-hand side. So we're going to move everything else over that's not a y to the right-hand side of the equation. And we do this exactly the same that we have with every other question that we've been rearranging. So the first thing I'm going to do is I'm going to look to see what sign is in front of this 3x. And there's no sign there, so we assume that that's a positive. So to get rid of a positive, I'm going to end up subtracting. So this was my 3x. I'm going to end up subtracting it. Plus y minus 5. And I also want to get rid of this minus 5. So if this is a negative 5, I'm going to add it so that I can get rid of that. Equals 0. Now, whatever I did to the left-hand side, I also have to do to the right-hand side. So here, if I subtracted 3x from the left-hand side, I have to subtract 3x from the right-hand side. And if I added 5 to the left-hand side, I also have to do that to the right-hand side. So let's look at this super quick. 3x minus 3x, well, that's going to go to 0. So those cancel out. Negative 5 plus 5, that also goes to 0. So these cancel out. So now I'm left with y equals, 0 plus 5, that's going to leave me a 5. So now I'm just going to have negative 3x plus 5. Okay? And now this looks like a y equals equation. And if I'm looking at this, this is in slope-intercept form, because if I'm looking here, I can tell that my slope is this number in front of my x, which is negative 3. My y-intercept is positive 5. Okay, so we're done here. This is math smiley face. Check mark. Okay, so now let's go down to this same equation. So I have 3x plus 5 minus 3x plus y minus 5 equals 0. But instead of getting y by itself, I want to isolate for x. And isolate just means, get by itself. So I want x by itself, okay? So to do this, I'm going to do exactly what I did in the first one, but I want an x equals equation now instead of a y equals equation. So everything that's not an x is going to go over to the right-hand side. All of my x's are going to stay on the left-hand side. So if I'm looking here, I need to get rid of this y, and I need to get rid of this negative 5. So I'm going to rewrite my 3x. I'm going to rewrite my plus y. But to get rid of y, to undo it, I need to subtract it. To undo my negative 5, I'm going to have to add it. Now, whatever I did to the left-hand side, I have to do to the right-hand side. So I need to subtract my y here, and I need to add my 5 because I did those things on this side of the equation. So if I'm looking here, plus y minus y, those are going to go away. That's like saying y subtract y. Those are gone. And then negative 5 plus 5, those are also gone. Okay. So that leaves me on my left-hand side with 3x equals negative y plus 5. And I can condense those because 0 plus 5 is just 5. Okay. One thing though, I want just x by itself. So if I'm looking up here, the goal was to have an x equals equation, but right now I have a 3x equals equation. So I need to ask myself what's happening between this 3 and this x. And the operation there is multiplication. So I need to divide to undo it. So I'm going to divide everything on both sides by 3, just like this. My 2 3's on this side, 3 and 3, those are going to cancel. That leaves me with x. But if I look here, there's nothing to cancel out this division, so I need to leave it. And in fact, I'm going to leave it as a fraction. Okay, so now this is going to be a fraction, and it looks like this. Fractions are okay in math, no calculator required. We're just going to leave it like this. So if I want an x equals equation, it's going to look like negative y plus 5, all divided by 3. Okay. Let's do one more example here. Oh, maybe 2 more examples. And remember that you can pause and go back and listen and kind of take in things if you're missing them. Don't forget to pause and copy out the examples for your notebooks. So in this example, I want to rearrange my equation to isolate for y, or in other words, I want to rewrite my equation so that it's y equals. So my goal here is a y equals equation. So I have my 2x plus 3y minus 9 equals 0. And just like before, everything that's not a y needs to move over to the right-hand side of the equation. Everything that has a y in it is going to stay on the left. So I'm going to rewrite my 2x here. X is not a y, so it needs to go. The sign in front of my 2x here is positive, it's plus, so I need to subtract it to move it over. I have my plus 3y, and then I have my minus 9, and minus 9 is also not an x, and to undo that, the opposite of subtracting is addition. Okay, and this all equals 0. Now, whatever I did to the left-hand side of the equation, again, I have to do to the right-hand side. So I'm going to subtract my 2x over here, as well as add my 9. And basically, you notice that I'm color-coding it. So my colors, my red, should look the same on both sides of the equation. Okay. So let's look a little bit more closely. 2x minus 2x, that's going to leave me with no x's. They're gone on this side. Negative 9 plus 9, well, that goes to 0, so they're gone on this side. So all I'm left with on my left-hand side of the equation is 3y equals. And then on my right-hand side, I only have negative 2x plus 9. Now again, just like in the previous example, I want to have y by itself, but this is saying that 3 y's are equal to this. So to undo this 3, I have to ask myself what's happening between my 3 and my y, and that's multiplication. So to undo multiplication, I'm going to divide. And I'm actually going to divide both sides by 3 because that's the number that's in front of my letter there. So I'm going to divide my left-hand side by 3. I'm also going to divide my right-hand side by 3. Okay. 3 divided by 3, that leaves me with y. And now let's look at this equation, okay? So, excuse me, I have a -2 and a 3. Nothing can happen here. So I'm just going to rewrite that. So that's -2x all over 3. But if I'm looking at this, I can do something with my 9 and my 3. In fact, 9 divided by 3 is 3. Okay? So I can simplify this a little bit. I'm going to keep the signs consistent. So there was a negative in front of this 2. That's why that stays there. There's a plus sign in front of this 9. So now I'm going to put that here. Okay? So this is just a little bit more simplified. All right. Last example here, kiddos. So I want to rearrange my equation. It's the exact same equation that we had. I'm going to isolate for x now. So here I have 2x plus 3y minus 9 all equals 0. And isolate for x means that I want to have an x equals equation. So I want x by itself. So anything that's not an x on my left-hand side of the equation needs to move over to my right-hand side of the equation. So I need to move over this plus 3y. I also need to move over this -9. So I'm going to rewrite my 2x. That's pretty happy right now. My plus 3y, to undo that, because it's positive on this side, I need to subtract it. And to undo this -9, I need to add it. Okay. And this all equals 0. And then whatever I did to my left-hand side, I have to do to my right-hand side. So this is -3y plus 9. Okay. So if I'm looking here, 3y minus 3y, that's going to go to 0. -9 plus 9, that also goes to 0. So that's disappeared from my left-hand side. That's the goal here. Good job. And then what's left on my right-hand side is a -3y plus a 9. Okay. So I'm almost there, but I do notice that I have a 2 here. So this equation is saying that 2 x's are equal to -3y plus 9. But really, I only want 1 x to be equal to that. So I need to ask myself, what's happening between this 2 and this x? And that's multiplication. So I need to undo that by dividing. I'm going to divide both sides by it. My 2's and my 2's cancel. That leaves me with an x. And if I look on my right-hand side, I know that 3 and 2 don't go into each other. I also know that 9 and 2 don't go into each other without leaving decimals. So I'm just going to leave this as a fraction over here. Okay. So I only reduce it if I can get even, nice even numbers, like in the example before where 9 divided by 3 is 3. Okay. I'm not going to do anything with this. I'm just going to leave it as a fraction. Check mark, math smiley face. So there's some questions to do on the attached worksheet. You're not going to do them all. I think just a couple, maybe like 6 questions. I'm also posting, and I know that that might take you a while, so I'm also posting a quick little kind of check-in with you guys. These are for marks, so please hand them in. It's an assignment on Google Classroom. You can submit it. If you have any questions, send me an email, but that will be there as well. I hope you guys are doing well and staying safe. I miss you all.